We're going to do the 8.1 notes on right triangle trig. The first thing that we go over is the complementary angle theorem. And what that means is that if you look at your unit circle, the cosine of 30 degrees is the same thing as the sine of 60 degrees. And 60 plus 30 is 90, because complementary angles add up to 90 degrees. So cosine and sine can be switched, tangent and cotangent can be switched, and secant and cosecant can be switched. So if I have the tan of 10, I can change that to cotangent and do 90 minus 10, which is 80. So those are the ones we can switch. So let's practice. The first example is the sine of 62. So I can change that to the cosine of 90 minus 62. And 90 minus 62 is 28. So the sine of 62 and the cosine of 28 equal the same thing. Then we have tan pi over 12. Tan can be changed to cotangent, and we're doing 90 minus pi over 12. But 90 in radians is pi over 2. And then we need a common denominator. So I'm going to multiply the top and bottom by 6. And 6 pi minus pi is 5 pi. For this last example, this looks close to our identity of sine theta plus cosine squared theta equals 1. So I can change this sine squared to a cosine squared. So sine squared 40 plus cosine squared 90 minus 50, and then 90 minus 50 is 40 degrees. And now that they have the same degree, just like in our formula, they both have theta and it's the same, so this simplifies to equaling 1. Next is just right triangle trig, so going back to using SOHCAHTOA. And I'm going to draw a right triangle and label it A, B, C. Where you put A and B doesn't matter, but C always has to be at the right angle. Our capital letters tell us the angle measure, and our lowercase letters tell us the sides. And where you place the side is across from the angle. So one thing we know is that angle A is 40 degrees. And we know little b is 2. So across from angle B, that side is 2. Now find all the other missing pieces. If we remember, triangles add up to 180 degrees. So angle B equals 180 minus 90 minus 40. So angle B equals 50 degrees. And then go back and make sure that you label your triangle. The next thing I'm going to find is little a, so the side across from A. And how I'm going to do that is through SOHCAHTOA. So I'm going to use right SOHCAHTOA up here at the top. And let's go ahead and use the 40 degree. So looking at the 40 degree, our A is the opposite and 2 is the adjacent. So looking at SOHCAHTOA, tan uses opposite and adjacent. So we're going to say tan 40 because the angle measure always goes next to the trig function, and then equals opposite over adjacent. And now we have to solve for A. So we're going to multiply both sides by 2 and have 2 times tan 40 equals A. You're going to plug this in your calculator and make sure your calculator settings is in degrees. And then from here, we would find that A equals 1.68. Now the last thing we need to find is little c, and with right triangles we can use Pythagorean theorem. So a squared plus b squared equals c squared. And if we simplify this, we would get that c equals 2.61. All right, Last example, again, draw a right triangle. So 8.1 is only right triangles, A, B, C. Again, C being at the right angle. Label what we have, so little a across from angle A is 3, and little b across from angle B is 2. The first thing we can find is little c, because we can do a squared plus b squared equals c squared, and b is 3. So 4 plus 9 equals c squared, that's 13. Take the square root of both sides, c. Now let's start with finding angle A. And I'm going to use opposite and adjacent, so 3 and 2. So tan is opposite and adjacent, and the angle always next to the trig function, which we don't know it, so I'm going to put A equals opposite over adjacent. To solve for A, we have to get A alone, and we do that by multiplying by the tan inverse. So A equals the tan inverse of 3 over 2. If you have an HB prime, how to enter this on your calculator is pressing Shift tan, and on up there should come up A tan. Once you plug that in, we should get that A is about 56.3 degrees. So I'm going to go ahead and label that back on the triangle. And then to find angle B, I'm just going to do angle B equals 180 minus 90 minus 56.3, which would give us that angle B equals 33.7 degrees. And that is all for this lesson. Let me know if you have any questions.